Black holes have fascinated humanity for decades, especially after movies like Interstellar. The idea that time slows down, light bends, and reality itself breaks near a black hole raises one big question. How much of this is real science, and how much is fiction? For most of human history, black holes were nothing more than a mystery, and until the 20th century, we didn't even know they could exist. The true story of black holes begins with Albert Einstein and his theory of relativity, which completely changed how we understand time, space, and gravity. Einstein's work came in two parts. The special theory of relativity explains how speed affects time. If someone travels close to the speed of light, time slows down for them compared to someone standing still. This effect, known as time dilation, has been confirmed by real experiments in satellite technology. Later, Einstein introduced the general theory of relativity, which revealed something even stranger. Gravity itself can slow down time. The stronger the gravity, the slower time flows. This idea was beautifully visualized in Interstellar, where 1 hour on a planet near a black hole equaled several years back on Earth. Einstein imagined space and time as a flexible fabric called spacetime. Massive objects bend this fabric, affecting everything around them, including light. If an object becomes dense enough, spacetime bends so extremely that light can no longer escape. Such an object would appear completely black. This was the theoretical birth of the black hole. Even Einstein himself believed black holes were only mathematical curiosities. He didn't think nature would allow such extreme objects to exist. But other scientists weren't so sure. Carl Schwarzschild found exact solutions to Einstein's equations, describing objects with gravity so intense that escape was impossible. Later, Subrahmanyan Chandrasekhar calculated the maximum mass a star could have before collapsing under its own gravity, a value now known as the Chandrasekhar limit. Years later, physicist John Wheeler gave these mysterious objects a name that would capture the world's imagination: black holes. To understand black holes, we must first understand stars. Stars exist in a delicate balance. Nuclear fusion in their cores pushes outward, while gravity pulls inward. As long as fuel remains, this balance holds. But when a star runs out of fuel, gravity wins. What happens next depends entirely on the star's mass. Average-sized stars, like our sun, expand into red giants before shedding their outer layers and becoming white dwarfs. Our sun will never become a black hole. It simply isn't massive enough. Massive stars, however, live fast and die violently. They expand into red supergiants and eventually explode in a supernova. What remains is the star's core. If that core is extremely dense, it collapses into a neutron star. If it's even more massive, gravity compresses it into a black hole. Remarkably, if our sun were compressed into a black hole, it would be only about 50 kilometers across. Not all black holes are the same. Stellar black holes are the most common and form from collapsing stars. Our galaxy alone may contain millions or even billions of them. Primordial black holes are hypothetical objects formed shortly after the Big Bang. They could be incredibly small, yet extremely massive. Supermassive black holes are giants, containing millions or even billions of times the mass of our sun. They sit at the centers of galaxies, including our own. The Milky Way's central black hole is called Sagittarius A star. Even the black hole featured in Interstellar, named Gargantua, was a supermassive one. There may also be intermediate black holes existing between stellar and supermassive sizes, though their existence is still under investigation. Despite their reputation, black holes are not cosmic vacuum cleaners. Surrounding many black holes is an accretion disk, a swirling ring of gas, dust, and debris. As this material spins faster and faster, it heats up to millions of degrees and emits powerful radiation, especially X-rays. While often shown as orange in images, the real emission would be invisible to human eyes. One side of the disk appears brighter due to a relativistic effect called Doppler beaming, where material moving toward us looks brighter than material moving away. Gravity also bends light so strongly that parts of the disk behind the black hole become visible, creating an optical illusion where the disk appears above and below the black hole. Closer still is the photon sphere, a region where light itself orbits the black hole. In theory, someone there could see their own back. At the boundary lies the event horizon, the point of no return. Beyond it, escape is impossible. even at the speed of light. Science fiction often imagines black holes as gateways to other dimensions. In reality, we simply don't know what lies beyond the event horizon. According to general relativity, the center of a black hole is a singularity where space-time curvature becomes infinite and known physics breaks down. Time itself would slow to a complete halt. Long before reaching this point, tidal forces would stretch and tear apart any object falling in, a process known as spaghettification. Despite their terrifying nature, black holes are not cosmic threats. Galaxies orbit their central black holes safely, just as planets orbit stars. As long as you keep your distance, black holes are no more dangerous than any other massive object in space. In 2019, humanity captured the first real image of a black hole, finally proving that these once theoretical objects truly exist. Black holes are not monsters of destruction, but natural consequences of gravity and time. They challenge our understanding of the universe and remind us how much there is still left to discover. If you enjoyed this journey into the darkest objects in the cosmos, don't forget to like, subscribe, and share. The universe is full of mysteries, and this is just the beginning.